Hello guys, my name is Hiraku Murakami. I'm here with NovaEdge Academics, and today we'll be going over part 2 of IB Physics topic A1 Kinematics. Specifically, we'll be talking about projectile motion and fluid resistance. So let's start off with projectile motion. Projectile motion is a study of predicting the movement of a projectile in motion. Okay, so this is very useful if I want to find out how fast an object will be going at a certain time, or how far an object will travel, or for how long the object will be in the air for, or how high it can get to, right? This is very important. If I want to throw a baseball, I want to know how fast it goes, how slow it's going to slow down, how much it's going to drop, etc., right? So for me to predict those movements, I can use math. And these are the equations that are given. I know they look a bit intimidating, but we'll be breaking down with problem sets together, okay? So first, I'm going to give you an example. A very simple example where I drop a ball from 5 meters in the air, right? I'm on the top of a cliff and I just drop the ball. Now, two things I want to know. I want to know the final velocity as it reaches the ground. And I also want to know how long the ball is going to be in the air for. So that's time in the air, okay? So I want to find v and I want to find t. These are the two things I want to find out. Well, let's discuss the things we know, okay? And for any problems like this, I always encourage students to write down the things you know. For example, I know that the displacement of the object during this air travel is -5 meters. So S is -5 meters. I also know acceleration of free fall is -9.81 meters per second squared, or just -10. And this is due to gravity, right? And I also know one more thing, and that is the initial velocity. How do I know the initial velocity of the object? Well, I know it's 0 because I'm just letting it go. So I start from 0 meters per second and it's accelerating as it goes down. So we know 3 things, we don't know 2 things. Now, why is this important? Because if you take a look at these equations that they look complicated, they always have 4 variables, okay? What does that mean? Well, we have 4 variables, meaning if we know 3 of them, I can find out the last one. For example, if I don't know S and I want to find out S, I need to know U, V, and T. If I know those 3, I can find out S, right? So that's what I mean by that. So right now, I don't know V and T. So let's take a look and find an equation where we know where there is S, A, and U. So S, A, and U, well, I can actually find out pretty quickly that it's this one. Okay? We know S, we know U, and we know A, but we don't know T. Okay? So we're going to isolate T and solve for it. So let's plug that in. -5, or S, so let's put it here. S is equal to ut plus 1/2 at squared. That's -5 is equal to 0t plus 1/2 -10 t squared. If I simplify this, I get that -5 is equal to -5t squared. I can cancel both sides out and see that t squared is equal to 1 second, or t is equal to 1 second. So the ball is in the air for 1 second. Let's find out v then. Okay, so now we know t, so I'm going to write it down here. How do I find v? I can actually use any other formula. Well, let's use this one, for example. v is equal to u plus at. So that's equal to 0 plus -10 t, which is 1. So that's equal to -10 meters per second. So when the ball hits the ground, it hits at -10 meters per second. That was quite easy, right? Let's do another one. Here I'm going to throw it up with 10 meters per second. Okay, so now I'm on the ground and I'm going to throw it up. Here's where it gets a bit tricky, because you need to divide this with the ball going up and going down. And trust me on this, we're going to get through this and you're going to see why. So right now, I know that u is equal to 10 meters per second. A is equal to -10 meters per second squared. But I don't know how high it will go, so I don't know S. I don't know for how long it will be in the air for, so I don't know T. And I don't know V, or do we? We actually know the final velocity at the peak is going to be 0, because the ball is going to travel up and come down, and at this peak, the velocity is 0 meters per second. Okay? And that's really important. That's why we split from going up and down, because if I combine those two, I have too many unknowns. I don't know how fast the ball is going to be launching at the ground, but I know it will be 0 at the top. Okay, so I know these three. Let's find t and s. Okay, for this I can use any of an equation that has the three things we know. So let's do this one. Okay, so 0 is equal to 10 plus negative 10t. If I isolate t, I get t is equal to 1 second. So it's going to be traveling up for 1 second. Okay, so now that we know t is equal to 1, I can use any other ones to find s. So let's do this one. S is equal to 10 plus 0 over 2t, which is equal to 5 meters. So it's going to be going up for 5 meters. Okay, so now let's do down. So we did up here, let's do down. For it to be coming down, I know that when it's coming down, the initial velocity is 0. I know acceleration is negative 10. And I know that the distance it will travel is 5 meters or negative 5 meters. We don't know t and we don't know v. Okay, those are the two things. In fact, this is the same problem as the previous one. The ball is just dropping from 5 meters. So I want you to give this another go and see if you get the same answers as we got here. You'll find that the final answer, t is equal to 1 second again. And so the total time that the ball is in the air for is 2 seconds. Okay. Now let's do another one where actually I am going to be throwing the ball at 10 meters per second up from a 10-meter cliff. Okay, so I already have a height advantage. So the ball is going to go up and come down like that. Which means obviously when it's coming down, the time is going to be greater. So how do we account for this? Okay, so we're going to be splitting it to up and down. I want you to pause and try this problem and let me know if you got it right. Okay, so let's do up first. At the top, it's going to reach a velocity of 0. So I know v is equal to 0. I know u is equal to 10 meters per second. And a is negative 10. So I'm going to do the same thing. I'm going to do this. 0 is equal to negative 10 plus by negative 10 t. Sorry. This is not negative, this is positive. So t is equal to 1 second. Okay? And then distance is going to be actually s is equal to 10 divided by 2t, which is 5 meters. So the distance to the top is 5 meters. Okay, let's do bottom. When we come down, I have to actually combine 5 meters and 10 meters because the displacement coming down is 15 meters. So s is actually negative 15 meters, u is 0, and a is negative 10. Okay, so let's use this information and we can find v squared actually. So let's do this one. So v squared is equal to u squared 0 squared plus 2as. Okay, and you're going to find that v squared is going to be equal to 300. So v is going to be 300 square root meters per second. And it's actually going to be a negative value because the velocity is going downwards. Okay, so keep that in mind. Okay, for the next part, we can actually use this one to solve for t. So s negative 15 is equal to 0t plus 1 over 2 negative 10 t squared. Okay, so negative 15 is equal to negative 5t squared. So t squared is going to be equal to 3. So t is going to be equal to square root 3 seconds. So let me know if you got the same thing. Now overall, I need to add the time. So the time that it came down plus the time that it went up. Okay, so 1 second plus square root of 3. That's the final answer. Okay, so we can do a projectile motion problem that's at a certain degree as well. So we've been dealing so far with just straight up and down, right? Well, how about I put an angle? I throw it diagonally at a certain degree. What happens next? Well, for me, I need to divide this into two sections. Okay, I need to divide it into two components. One is in the y component and one is in the x component. And the reason behind this, okay, the reason behind me needing to split this into two components is because gravity works in the y component and I need to know the velocity in the y component only. So kind of another way to picture this is as if the ball is being thrown up like this, but at the same time it's also going to the right. And combining these two, I get this motion like this. Okay, now why do I split this? Because this gives me the time that it's in the air for, or how it behaves vertically, and this gives me how it behaves horizontally. Okay, so if I split this into two, well, I need to use trigonometry for me to split these into two. Okay, so first, the velocity in the x component, let me call it ux subscript x, is equal to 30 meters per second cosine 30. Okay, and the y component, let me call this uy, is equal to 30 sine 30 degrees. Okay, and this is simply 15. This is simply 26 meters per second. Okay, so I'm going to ignore the x component first, okay, because I just want to figure out how long it's in the air for. Okay, so let's figure out how long it's in the air for. Well, this is a simple problem that we've been doing like that, right? This is the same thing, except now it's 15 meters per second. So u is 15 meters per second, a is negative 10, v is 0, and I need to figure out t and v. Okay, well, v is going to be, okay, let's use this guy to find t. Oops, sorry. Okay, let's use, I apologize, this is s. Okay, so let's use this guy to find t. 0 is equal to 15 plus negative 10t. So t is going to be equal to 1.5 seconds. Okay, and now I can use any of these guys. I'm going to use this one. S is going to be equal to 15 divided by 2 times 1.5, which is going to be equal to 11.25 meters. Okay, so the ball is going to, the peak height of the ball is going to be 11.25 meters. So let me draw the trajectory. It goes like this, right? So the peak height is 11.25 meters, and it's going up for 1.5 seconds, which I actually now know that coming down is also going to be 1.5 seconds. So this is something that's with symmetry. You're going to see like here, if it went up for 1 second, it comes down for 1 second. We can't apply that for this problem because you're on a cliff, so coming back down takes a longer time. So for this one, I already know that it is 3 seconds. So time in air is 3 seconds. Okay, and it's also going to be coming back down in a vertical component. Vy is going to be equal to 15 meters per second. Okay, now I also want to know how long it traveled in the horizontal direction, right? How far did I throw the ball? Okay, and I can find this because now I know how long it was in the air for, 3 seconds. So the distance in the x direction is equal to ux times it by t, and that's equals to 26 times it by 3, okay, which is equal to 78 meters. Okay, why is this equation valid? Where did I pull this from, right? Well, I just pulled this from knowing that distance is equal to velocity times time. But why did I not need to use any of these equations? Well, that's because there is no acceleration or deceleration in the x-axis. In the y-axis, we had an acceleration of negative 10 because of gravity. But in the x-axis, there is no acceleration. I'm not adding any force. I'm not subtracting any force, right? So there's no acceleration or deceleration. The velocity is constant. So the ball is traveling in the x direction for 26 meters per second constantly. Okay? So I just need to multiply by time to figure out the distance traveled. Okay? Yeah, so now I know that it traveled for 78 meters. Now, if I were to combine it with, let's say, a cliff problem, then it becomes tricky. Okay, so let's do this problem. A stone was thrown upwards from a height 1.6 above the ground with a speed of 18 at an angle of 52. Assuming that air resistance is negligible, calculate its maximum height, etc., etc. Okay, so I actually do this. So it's 1.6 meters. I'm throwing the ball 18 meters per second at an angle of 52. Okay, so first let's divide it into 2. Let's find uy, ux. So uy is equal to 18 sine 52 degrees, which is equal to 14.2 meters per second. I know A is negative 10 and V is 0. Using this, I can find that time is, I'm going to use this equation, 0 is equal to 14.2 minus by 10t. Okay, so t is equal to 1.42 seconds. This is going up. Okay, I can now find the displacement going up. So that's equal to 14.2 divided by 2 times 1.42. That's equal to 100 meters, about. Okay, so 100 meters to the top, that's my peak height. Let me just make sure. It sounds sus. Apologize. So that is 10 meters going up. Okay, so 10 meters. Alright, so the ball is going to probably travel like this. Right? So it's going to be traveling like that. So from here to here is 10 meters, which means its maximum height is 11.6 meters. I need to combine with the cliff. Let's do part B, the vertical component of velocity when it hits the ground. And, okay, so I need to measure the Vy at the end here, okay? So for me to do that, I need to do the down now, okay? So I'm going to actually clear up a little bit. Coming down. Okay, coming down, I know the displacement is equal to 11.6 meters, or negative. The initial velocity is 0, okay, because it's like dropping. A is negative 10. Using this, I can figure out I can use this one. So negative 11.6 is equal to 0 plus 1 over 2 negative 10 t squared. Okay, so and simplify this, and you're going to find that t squared is equal to 1.52 seconds. Okay. All right. So sorry, t is equal to 1.52 seconds. Okay. So time that it's coming down is 1.52 seconds. All right. Cool. Now I can find out the velocity coming down. The velocity coming down is this. So v is equal to 0 plus negative 10, 1.52, which is equal to negative 15.2 meters per second. All right, so negative 15.2 meters per second. Cool. All right, so I can actually answer a lot of things. B is negative 15.2. C, the time taken to reach the ground, is just the total time. So that's 1.42 plus 1.52, which is equal to 2.94 seconds. Okay. D, the horizontal distance that it traveled. Well, I can multiply ux by time like last time. Ux is equal to 18 cosine 52, which is equal to 11.1 meters per second. So multiply that by 2.94, and I get 32.58 meters going to the right. Finally, E, the velocity of impact. What do we mean by velocity of impact, and how does that differentiate from B? Well, this is me crashing at this point, right? The velocity at which I'm impacting both the y and x component. So the B is only the y component. The y component I know is 15.2. The x component I know doesn't change, 11.1. Okay? I use a quick Pythagorean theorem. Okay, this is what we want. This is 15.2, 11.1. So this is naturally 15.2 squared plus 11.1 squared, square root. That's going to be equal to 18.82 meters per second. That is the final answer to E. Okay. Last but not least, some trick questions. So we have on the left side a baseball player throwing a baseball, and on the right side we have a man shooting a gun. So which one do you think is going to be in the air for longer, right? So the ball or the bullet? So pause and think. The answer is they're going to be in the air for the same amount. It doesn't matter if one is going faster horizontally, they're going to be in the air for the same amount of time. Part 2, which one travels further? Well, they're going to be in the air for the same amount of time, but one is going faster. So the bullet is going to travel further. Okay? So last but not least, I'm going to talk about fluid resistance and terminal velocity. Okay? In the previous problems, we've completely ignored something called air resistance. And air resistance is the air that you hit when you're traveling at a fast speed. Well, it turns out that this resistance increases as you travel faster. Okay? So the fluid resistance increases as you travel faster. Now, at one point, you're going to reach that there's going to be, we're going to cover this more in depth next session, but at one point, you have people that's coming down at a certain force, and the fluid resistance, let's call it FR, okay? This fluid resistance is balancing against the weight force. In this scenario, we say that terminal velocity is reached because you're no longer accelerating further. Your velocity is constant. This is the maximum velocity achieved in this scenario. This is what we call terminal velocity. Okay. Now this is a diagram here where we show with air resistance versus without air resistance. This is what we used without air resistance to calculate using the math. Okay. But with air resistance, it's going to be like that. Okay. So we're going to finish here. I'll catch you in the next one. Hey guys, thanks for watching the video. If you find these really useful, then consider giving us a like and subscribing to our channel. For questions, leave them down below in the comment and we'll try to get back to you. For more academic resources, visit our website at NovaEdgeAcademics.com. We offer one-on-one tutoring service as well as college admission strategy. Let us know what you'd like us to cover next, and we'll see you in the next video.